Thank you. So let's start talking about what is Mercado Libre. Let me introduce you, Meli, that's how we call it on the inside. And from now onwards, I will name it that way. There are a couple of things to understand the whole concept of scale. One is the business scale, and the other is the technology scale. Mercado Libre is the biggest e-commerce platform in Latin America. We have more than 75 million active users. We sell 250 million items every quarter. We are present in 18 countries and have more than 34,000 employees. On the other hand, technology-wise, we have more than 24,000 microservices running on top of 10,000 virtual machines and run in 4 major clouds. We built an ecosystem in which every single product and component gets stronger built on top of the rest of them. And that's how we have been thinking stuff to be stronger. The only thing that we think we could be able to handle this level of complexity is through abstractions. So let me introduce you Mary, who is a backend developer at Mercado Libre, one of our business units. She's a backend developer using Java, of course, and she needs to solve a specific problem. So what we did to help Mary solve her problem is to build a platform, kind of a platform as a service offering, which is an in-house solution, in which we develop a set of features, one on top of each other. We call them capabilities, networking, compute, and CI, CD. And Mary, the only thing that needs to focus on is just develop software, right? That's what Mary sees every day. She has a lot of things related to her application, operations, cost metrics, traffic, and she has specific services. These services are software as a service offerings, which are another layer of abstraction layer that we build, and that's what my team does. These services just solve purpose-specific things. For instance, a key value store. Instead of them having to use Cassandra or DynamoDB, they use our own SDKs to solve a key value store problem. We solve centrally maintenance, cost effectiveness, security, and so on. So why Pulsar? Why we chose Pulsar to be in the heart of this platform? We based this decision in 4 pillars. The first one is about scalability. Our company grows twice a year over year, and it's really important to have a scalable solution. When we started and when we decided to do this, to have a transparent design was also key for our decision, because we needed to know how this works in order to be able to maintain it. Also, low latency was a must, and Pulsar is really, really good at that. And last but not least, consistency. We, for instance, handle money, and money needs to have certain guarantees. If a message is acknowledged, you need to be sure that that thing would be delivered, right? So we started with 2 very, very big clusters to handle the whole solution, and we scaled out and rethinked our solution, having more than 30 productive clusters. This all in the same region, multi-AZ, and started rethinking how we should design our system. So how Pulsar, how we came up with this, how we built our ecosystem on top of this. First thing is our abstraction. our client application, our producer applications don't know about the specifics, in this case of Pulsar. They just know about our custom SDK and go through an API that routes messages. And that API is the only one that knows about Pulsar specifics. The messages go into the backend, and then there's another API that pulls these messages out of the backend and delivers the message. For instance, Mary, the only thing that she has to do is to configure an endpoint and to configure that she wants to receive messages from a specific topic. Imagine this having more than 15,000 topics and 25,000 subscriptions. So what's the advantage of this? The consumer applications can be built on any message, any language you can imagine. They will just receive an HTTP post with a message with a known envelope. There are no SDKs, no nothing. Just to be there to receive it, and they configure what they want, where they want to receive the message. That gave us the chance to build a set of features on top of this abstraction, regardless of the backend being able to support it or not. These features include, for instance, filtering. When the producer sends the message, they tag them with a specific information, and the consumer level, they can choose which messages they want to receive. So when we are to deliver the messages, we choose if we need to deliver the messages or not. One important thing is that on the consumer side, based on the status code, we choose if we acknowledge the message or not to resend it. So when we filter the messages, we just acknowledge the message regardless of, we don't send anything to the consumer, right? Other sets of features can be, for instance, bulk production and bulk delivery. A producer can send a bunch of messages at once, and at the consumer side, we send a bunch of messages and use a contract to receive specific message level status codes. And for instance, another important thing is rate limits. Regardless of the amount of messages that we receive on the topic, the consumer can say, I can only support receiving 10,000 messages every minute. So if there is a peak in traffic, we will handle that for him. We will just wait and deliver the only amount of messages that he chose. This is how a Pulsar cluster looks for us. This is the main three components of Pulsar, bookies, brokers, and zookeepers, in a specific virtual private cloud, in AWS in this case. And the weird thing is that we use auto-scaling groups that don't scale because this is a static infrastructure. And in another VPC, we have the only APIs that can access the Pulsar components. The producer API, the admin API, and the consumer APIs are the only ones at firewall level that can access the brokers or the zookeepers. This way, the whole security is simplified to that. There are another important things about cluster layouts, which are general and not that infrastructure specific. For instance, we designed to have BU-specific clusters in order to reduce blast radius in case of an outage. Also, we have multi-AC design. All these auto-scaling groups balance instances in 4 availability zones, so in case of an AC outage, we don't get all the cluster down. Also, we defined a split threshold. If we are to receive more than 2 million messages every single minute in a specific cluster, we just trigger a new cluster creation and start creating new topics on the new cluster and get the existing one like it is. We also have a failover solution, and we have to test failovers every single week. So let's talk about failovers. In this diagram, I can show that there are in this case, 4 productive clusters, and let's imagine that we have an outage on cluster 4. So what happens here is that the admin API gets sure of having every single topic and every single subscription created on the failover cluster. And if that's true, the producer API is the one that does the magic, and it just switches production to the other cluster. Because it will have every single topic, he will just switch to another endpoint and produce elsewhere. And the pusher API will just try to pull messages from the failover cluster and from the productive cluster. We need to be sure that we are not overwhelming rate limits, so it's really important to define how many messages are being pulled from the failover cluster and how many messages are being pulled from the productive cluster. But the really important thing here is that this gives us the chance to fix a broken cluster with no downtime. Production is just going through to the failover cluster, and we are able to fix the broken one. Of course, messages that got into the productive cluster need to get out of there. I mean, it's not perfect. So how did we design a team to handle this? It's just a simple design, 8 members, no big differentiation between dev and ops. Mostly we are devs, but we have an on-call rotation, which sometimes it got funny, you can imagine. And we defined certain thresholds defined on the specific outage types that, for instance, not less than 4 members need to be ready when there is a major outage. One of them needs to communicate to the rest of the company, and in the meantime, there are 3 guys just trying to fix what's the problem, right? We also built a lot of operational tooling, monitoring, as I said, failover, topic migration, which is a very important feature when there is a topic that is hurting a cluster. We just switch production to another cluster. We create this topic in another cluster and pull the messages from the original one and from the new one, and we can topic granularity to move it out to another place, right? We also have been able to build for new architecture types, for instance, Graviton, ARM, in order to be more cost effective, right? So let's talk about how did it go? How was our experience reaching this scale with Pulsar? Well, in a normal minute in Mercado Libre, we receive 35 million messages. It's kind of common for us. We have lots of microservices and this distributed source of truth thing in which you send a notification in which there has been a change and the other APIs just go to the source of truth to check what's the next value for a specific resource. But at the same time, we are delivering more than double that number because as a matter of cardinality, there are topics in which you have 500 subscriptions and you need to deliver every single message 500 times, right? On the other hand, we filter more than 80 million messages every single minute. The consumer doesn't receive anything, but we need to acknowledge 80 million messages every minute. Let's talk about which are the Pulsar wow things. Latency, if we build a top list, will be in the first, second, and third place because it's really, really a good thing. Horizontal scalability is also a really, really nice thing about Pulsar. Bookies and also brokers are really, really easy to scale up. Maybe not that easy to scale down, but it's kind of a trade-off, right? And the third thing is time to delivery. when you ingest a message, it's almost instantaneously ready to be delivered, and that's a really, really important thing. There are also a bunch of not so good things. Some of them are just our fault, maybe poor design on the namespaces or topic partitioning, in which we decided not to consider topic size, and we just flatten out 10 partitions for every single topic, and that can get really, really harmful. Also, we decided to use one namespace per topic, which is a really, really negative decision. We also have had an issue related to updates. It gets a little bit difficult to be up to speed with updates if we are not used to be at the almost latest version, right? New features like tier storage, we also didn't come up to speed with that. And there are also a bunch of things that can really hurt a cluster, but we started learning about that. For instance, as I mentioned, high cardinality. If you have a cluster in which there is one single topic that has a lot of subscriptions, it can really, really hurt the specific brokers that are assigned to that topic. Also, high filtering. There are some funny use cases in which a specific subscription should receive 100,000 messages every single minute, but he will filter 99.99% of those messages. Acknowledging all of these messages really, really can hurt the cluster too. Sorry. So let's get to a couple of anecdotes of our experience with Pulsar. You can imagine, for instance, being 5 minutes before New Year's Eve, fixing a broken cluster, but we fixed it, and it was kind of the whole family waiting over there, and yeah, woo! Another thing is about the Liebenstein distance, in which we have had a cluster named MP01, and there was a guy creating a new cluster, MP02, but he went to the wrong zookeeper, and he wiped out the whole metadata for the cluster, and the key learning here is don't be a fool, backup is cool. And the third thing is, as I mentioned before, an autoscaling group which is paused, but someone had the brilliant idea of unpausing the autoscaling group, and it wiped out 8 bookies in a second. And the funny thing is that it was kind of winning the lottery, because we didn't lose any data apart from 3 specific topics, which was, what's the probability of that? It's near 0, but it happened. So we can also be kind of proud of being authors of new anti-patterns. The first one is the too fast. And can be too fast negative thing? Well, if you build solution relying on having a messaging system that needs to give you an OK status code before 5 milliseconds, you are in trouble. Because when this cluster gets slower, the whole system is just kind of a domino effect, right? The other thing is, if there are no order guarantees, don't try to order artificially things. Human creativity is kind of limitless. One other thing that is really important, there's a new feature, at least new to us, which kind of solved this problem, is the errors and retries. As I mentioned before, we just push the messages, and depending on the status codes, we decide to redeliver the message or not. So think of a case in which there is some fork and join thing in which there are triggered 3 different messages, and one specific consumer needs to wait for the other 2 to finish in order to have the resources he needs present for him, right? So the only way they could handle this is returning an error and waiting for us a lot of seconds after to resend the message. When you have a subscription that all the time is returning errors and returning errors and returning errors, it can get messy. I'm not the football player. And the most famous anti-pattern, which is the silver bullet, they started using a messaging system for whatever you can imagine. Sending logs, sending, I don't know, information that maybe no one reads, and it kind of got bigger and bigger and bigger. So, which are the key learnings and takeaways, in my opinion? First thing is the abstraction. The abstraction is really important for us to be able to trust, but not to only rely on a specific backend. We rebuilt our routing API in order to be able to switch between backends in a transparent way. Developers don't have to change a single line of code, and we can, for instance, switch in a percentage production to another backend, and we need to choose how to pull the messages to be delivered to a specific subscription, and that's it. The other thing, I don't know if there is a Zookeeper fan here. Sorry, no regrets, but I hate Zookeeper, sorry. It kept me sleepless a lot of nights, so I'm really proud of seeing that you are getting out, or at least building a solution that doesn't only rely on Zookeeper, which is a really, really good news. Also about storage. If you don't design storage, and there is a storage or floating feature for that, but it gets really, really important to design your solution based on an efficient use of storage, because it can get really, really pricey. Infrastructure design. Our infrastructure pattern and design was kind of simplistic, and I guess it was a major pitfall for us to have that simplistic design, because when you need to scale up and down, it can get really, really difficult. And the other thing that I need to repeat is about Pulsar's wow things. Pulsar's latency is unique in the market, and it's really unique. The last message I'm here to give is about, in my opinion, what's the Pulsar's game. We are in a really, really competitive market, in a multi-cloud environment in which cloud providers have their own solutions. They are good at what they do, but Pulsar has really, really unique things. Also, I guess that here we have two different types of audiences. Maybe there are Pulsar users and there are Pulsar maintainers on the same tables. For Pulsar users, my suggestion is to share. Share your experience, share your knowledge. When you get, for instance, trying to start using Pulsar as a startup, you kind of think, do you hate me? I mean, I just need to create a topic and a subscription. Please help. So it's really, really important to share experiences, to share that it can be really simple to do this. On the other hand, for maintainers, and I can see that you are in that way, which makes us really, really happy, is that the game here is, in my opinion, not to try to be the one and only solution, but to be just collaborative, just to be part of an ecosystem in which a company may have one backend and another backend, and you need to be cost effective, you need to be efficient at batching, and to be thinking about standards. For instance, cloud events, Camel, OpenFast, I don't know. Think about whatever you want, and there are other talks related to Apache Beam, Flink, and really, really is important to think that there are many, many different use cases, and the one and only solution needs to be adapted for that. So thanks for your time.